Hello and welcome everyone to AI CSI, a co-located event dedicated to AI and cybersecurity and cyber intelligence. My name is Mirjana Jelic and I will be your host today. I would like to welcome everyone in front of our organization team of the Data Science Europe 23, and we are happy that you are joining us at the biggest AI event in Europe. We will now begin, and with our first talk today. So please welcome our opening keynote speakers, Dragan Pleskonjic. He is Senior Director of Application Security. In his current role, he directs, coordinates, and oversees application security efforts on the global organization level. Sorry. He possesses rich experience in creating and managing startups, new business development, and has proven leadership and talent for creating, managing, and organizing successful teams. Dragan is an adjunct professor for various cybersecurity and computer science courses. He is the author of 10 books so far, including university textbooks on topics such as cybersecurity, operating systems, and software. Please welcome, as well, his colleague, Vladimir Jelic. He's Senior Manager Application Security, and in his current role, he participates in application security efforts on the global organization level. His work includes software security assurance, static code analysis, work with static application security testing, and software composition analysis tool. They both are coming from IGT, and they will present their talk titled AI Impact on Cybersecurity and Privacy. Please welcome.
Thank you very much. Can you hear me? So thank you for this introduction, and thank to organizer for inviting us to talk. We will talk today about how artificial intelligence and machine learning affects cybersecurity and software security and privacy. And we will mention that through theoretical and conceptual part, and also we will have demo, which will do my colleague Vladimir, who is there, which we will show you that it really works. So it's not just kind of PowerPoint, but it works. That's very important. I'm trying now to move to next slide. Something with the reception is. You can manually move until we. So a couple of words about me. I got a beautiful introduction by host, but just to say, 10 books so far, most of them university textbooks. That's one thing. 9 patents granted so far by US Patent and Trademark Office, double digit of startups so far, most of them with successful exits, mostly in USA and UK, and also number of industry projects, I think hundreds of them in area of software security, network security and similar areas. I developed number of companies, so that's, I think, something. Part of that, university career with more than 90 scientific papers. My colleague Vladimir, he is waiting behind to show demo later on. He works with me for more than a decade, and we're developing interesting solutions. Just to say, which I'm obliged by company, which is on New York Stock Exchange. I talked here on my personal and Vladimir behalf, not on behalf of company. We are obligated to say that because of policies of stock exchange companies. So that's something that we have to say because, you know. What is interesting? Now or today, $10.5 trillion is security crime. Can you believe that? Trillions are US, so I think it's 12 zeros, but that's a big number. And the investment in cybersecurity is 6 times less. It's 1.75 trillions. So investment is 6 times less than crime size, and it's, I think, big industry. Also, average breach costs almost 10 millions. That's for North America, not globally, but it's big, really big number. And what is happening now? Companies want to invest into cybersecurity, and when they investing, that means that they want really something what can protect them. And they found that artificial intelligence and machine learning can be very helpful. And you see that CAGR, compound annual growth rate, for next, I would say, 8 years, is almost 24%. So what is going on here is actually huge investment which will be poured on AI and machine learning use in information security. Why is that important? Because people and management of companies really takes this seriously. What we will show today, first, every one of you know what is AI, but just will show a couple of definitions to agree about, because I heard from my colleague 2 people, 3 definitions of AI. So probably that's true. And how it affects cybersecurity from attacker side, and also how it affects cybersecurity from the defense side. And we are on defense side, so we are defenders. And also what are future opportunities and concerns. And then, as I said, we will show something how it works, really. What is AI? I would just point to Kantrovich's definition, which is 40 years old. And there is weak AI and strong AI. And you probably know what the definition said. But I see today that everything is called AI. Actually, statistical methods are sometimes called AI, which is very question for discussion. And when we talk about use of AI, everyone talks about self-driving cars, about medical diagnostics, about many things. But very few people talk about use on cybersecurity and software security area. And actually, this area is, I think, on one of the top 3 investments globally in AI industry, but not so much visible as probably people can see. And in current state, I would just point a couple of things which you can see here. But one very interesting thing, I assume most of you are from IT, from software development, is GitHub Copilot. You use that to tell him, develop me this code in standard English or in future Serbian probably. And that Copilot give you code which is really good sometimes. But sometimes it's not so good. It hallucinates sometimes. So you can get really good help from these tools. One interesting thing, however, Copilot give you code which is vulnerable to security. One recent research, not so recent actually, 2 years ago, said that 40 to 45% of code developed by Copilot has security vulnerabilities. And you know why is that? Anyone? Yes, exactly. It actually learns from humans, and it introduces as much as security vulnerabilities as humans do. So all what they learn, they do and mimic human behavior. We need to take care about that. So perspectives here, one is attackers. And interesting, attackers are a little bit advanced, more advanced than defenders. Why? Because hackers, malicious hackers, I don't like hackers in negative context, but malicious hackers, that's specific strain of hackers, they do that and they attack your systems. And there is a view from defender side, and that's battle which is already started, and that battle is ongoing and probably is there to stay for a long time. So eventually someone said it will be machine against machine, or AI against AI, or from both sides. Here are some interesting examples, and I would not go to all of these examples because you probably know most of them, but I would kind of reflect to recent elections in Argentina. They use deepfakes to kind of put what people are saying, which is wrong, and we can expect that more and more. So they put your video and your mouth and your facial expressions, and put some words that you never told. So deepfakes is interesting, but what will then happen? It will happen with banking applications which rely on video authentication. Can be really dangerous. Another thing, I know the case where CEO of one company was filmed. His voice was kind of recorded, and his facial movement were recorded, and he sent video message to his CFO to pay some millions to some account. And his CFO saw his face, his tone of voice, and he did it. So you cannot trust your eyes and your eyes anymore. But that's very dangerous now. And phishing attacks becoming really sophisticated, and you hardly can distinguish between real mail and phishing mail with AI. And that's going to be very, very interesting in future, in business email compromise and other things. Also, interesting thing is malware. Malware which can detect antivirus and other techniques. So you can go, in this presentation there is link. You can go to this website and put your image or image of your colleague, put text he or she needs to say, and you will get that person saying that. That's very dangerous if you are not ethical. So regulation is needed here, really. So we cannot solve these issues by technology, but we can solve that by legal and organizational measures. 3 things here which I choose to show is Black Mamba. Probably you heard about Black Mamba. This project is actually, I think, IBM project, which is actually generation of polymorphic malware. Malware which changes itself by its behavior. So it's not easy to kind of distinguish that malware and real benign code. And also Deep Locker, which actually is new breed of ransomware, which will not be able to be detected. We won't be able to detect in easy way because it is kind of avoid most of current today detection mechanisms. So we need to fight against that. And you probably heard about ChatGPT, but I don't know if you heard by Worm GPT. It's cousin of ChatGPT, and you can ask that tool about very nasty things. And they will help you to hack and others if you are not moral, you're not ethical. And interesting, we work in AI, and we see a lot of biased data sets. You know, data sets are very important here to train. And we noticed that people kind of change data sets to get better results. That's scientific community. But there is malicious set of malicious actors, usually government sponsors, that inject vectors in data sets which primary purpose is to kind of mess with the learning algorithms. So if you are a researcher in this area, be very, very careful which data sets you trust. There is a lot of public data sets on the internet which are purposely made to kind of attack your machine learning models, AI models. And that's just one way how you can do that. There is a lot of attacks and scientific papers and practical implementation of these. When we talk about general AI and cybercrime, I would say that also people try to attack machine learning AI models, meaning to kind of reverse these models and use them in subverted form. So it's something what is going on to be next battle, I believe, or battle that is already ongoing. How will we fight against that? Here are kind of 6 areas, just quickly. And I would point on weaponization of cybercrime tools. On black markets, on dark web, on elsewhere, you can find a lot of software which is actually commodity now. Even people with very limited technical skills and security skills can use that. And also, what is needed here is better risk management, which will take in consideration this type of vulnerabilities, this type of risks. And security processes are constantly updated in big companies, mine included, but you have that for old-fashioned systems, and we need to do that for really new type of attacks and new things that are coming. One important thing which is out of technology is actually standards and regulation, and fight against actually that on legal level and on intelligence level. So it's going far beyond the technology. And I believe that a couple of future concerns are here very important. One is how to detect AI-based malware and how to make sure that they will not learn defense algorithms and anti-malware algorithms to detect them. So it's fight actually how we detect them, how they detect us, and how they cover tracks and how we do that in opposite to protect ourselves, etc., etc. And what is challenge here? Actually, a challenge here is that current security tools mostly have issue of false positives. They fire a lot of alarms, and 80 to 90% of alerts on current SIM or tools in software security are things that are false positives. People spend a lot of time on that, and then you can recall Serbian story about Vuk or Wolf. When one, I will say this in Serbian, mladi čobanin je govorio Vuk izvezao seljane i onda kad je stvarno došao Vuk, nisu ga više spašavali. And another thing, when you really trash out false positives, filter false positives, then you need to do remediation. It's interesting from practice how many people, even in security area, don't know what to do when something comes out from security. So how to fix, how to remediate issue. And we developed 4 projects in our team. One is Impressec. It's actually looking into traffic on network, computer network or mobile network, internet, whatever. Find out, based on AI models, which sessions, TCP/IP sessions are malicious, means attacks or threats or exploits, and tell that to people. That's one thing. And then it can be done also on endpoints like a laptop, server, mobile phone, whatever. When we worked on that, we found out that we see a lot of so-called blue sticks, something what is not critical or not even high or medium, but it precedes something what will happen in 2-3 weeks. So we can kind of predict that someone will be attacked in 2-3 weeks or 2-3 days or with some probability. And we extended that algorithm to projects called security predictions. And interesting that most of companies don't have security staff. Security people are expensive, require a lot of good salaries, etc., and other things. That their job is not easy. So we created Virtual Security Operations Center, which can help companies to protect their companies. And additionally, we developed GLOG project. GLOG is tree which immunize with their fruit and flower human body. So we immunize with GLOG software. We check software and find out security vulnerabilities and tell to people based on AI how to fix that. And we will show that today. In Impressec, we have 6 components. I would just point on sensor, which is network, detection of malicious TCP/IP sessions, threats, attacks, or exploits based on ML. Second one is agent, which is on endpoints or pass-through devices. So you know endpoints, I said, servers, laptops, mobile phones, etc. And the pass-through devices are firewalls, routers, access points, whatever. And server is a component which keeps all the new models, and trainer is a component that gets new data vectors grouped in data sets and then creates new models which are distributed through server, etc., etc. It does basically classification on a holistic level, what is good and what is anomaly. Anomaly means dangerous, and that tells to security analysts. And we have concept security analyst in the loop. What that means? Person who is security analyst can agree with AI model or can say AI model is wrong. We gather all the feedback from real persons, and we learn for security analysts. So this concept is called security analyst in the loop. And the deployment can be on cloud or can be on premises. Still, some people don't like cloud, and we honor that, so we have both methods. Here is just one example of deployments of sensor. What is important here, we get some specific data, which give us information gain. And when we then go to set of classifiers, which first one says is good or bad, and then next say, okay, this is this severity and this probability to be good or bad. And this is this orange dots say denote positions of components in our system. And here is Virtual Security Operations Center. I said what it served for, so I will just skip over there. I am rushing through this part because we have demo later on and we have limited time. It will be around here, so you can ask questions if you have later on. And threat intelligence, you see, I said we can predict who will be next victim of attack. This is a tricky one, and there is a lot of parameters we showed here. 8 groups. And you see some technical and security things, but also you can see some which are not security things, like psychological things, like social, financial, even geopolitical and geostrategical. In the current world, there is a lot of fight between countries. We see that on our dashboards. If you are security, you will see political turmoils on dashboard on security of our tools. So it reflects really in big time these things. What we get here, we actually got accuracy of this, which is after kind of a couple of weeks of learning new environment, which is better than 99%. So false positive rate and false negative rate is very low, and we save a lot of time and money and effort to security people. That's important. In software security, I don't know how many of you are aware of static application security testing, interactive application security testing, dynamic, etc., etc. And you know that all tools on the market today, even leaders, have a really huge number of false positives. 80 to 90% of false positives, even Gartner Magic Quadrant and Forrester Wave leaders have. And we cannot cope with that. We spend a lot of time on that. So what we need to do, we need to trash out that false positives. We need better tool which will trash out that and which will point real security vulnerabilities. And then we will need to tell to software developers what they have to do in order to fix these issues. Believe me, even senior software developers are not well trained for software security. And when we tell them you have here some kind of session forgery, cross-site scripting, SQL injection, they don't know how to prevent it. It's real life. So we need security remediation advice. Even we need tool which will fix code instead of people. And we developed that in GLOG project. And what we do here is actually we have that in these words. Triage issues, flag false positives, and give remediation advice. And ultimate goal is automatic remediation. Also, there is implementation on cloud, on premises. Also, plugin for most used integrated development environments, so developers in real time when they developing code can find out what is going on and what they need to fix. And also, famous CI/CD pipeline and agile processes. It can be also per project or per number of findings, etc., like service, not just product. And here is DevSecOps process, and where is GLOG positioned? Just to say we look not just in code, but also threat model and software security architecture and security requirements. So not functional, but security. And we call that extend to left. You know, there is famous shift to left. We say, no, we don't need to only to shift to left because the right side will be uncovered. So we need to kind of shift left and cover entire SDLC, software development lifecycle. And one example, from more than 10 years working in application security, or maybe even almost 20, you need 2 to 4 hours to fix one security issue in code. And if you have in very, very modest application, 1,000 findings with current tools, that's 2,000 hours, minimum. That's how much? That's like 15, if I count well, man months. 12 man months. And who can invest that time if you rushing to deliver something to customer? And what we need to do, we say, okay, there is a lot of false positives. We don't need to bother with that. We're losing the time. And we then invite AI to help us. And then we had a real life example. We were tested by one Israeli company, which is in application security, one of leaders. They asked us not to say their name publicly. You will see why. They gave us 2 projects with 12,500 findings, 25,000 hours, which is almost 14 man years. Globe did this in 4 man days. So this is real result. And which advantages of this system? Just shortly, advantages are actually we detect what is problem, real security vulnerability. We fix them in a way, tell developers you need to do this and this, to change these 10 lines of software to these 5 lines, for example. Or you need to change this in your software architecture. And the ultimate goal is actually to automatically fix that. And we can put that on GitHub or Bitbucket as action. So you check in your code by end of your working day. Tomorrow you come, your code gets fixed in mysterious way by wizard. So you don't need to bother. That's ultimate goal we're working on. We are close to that, and we can show that. Vladimir will show that later on. So we need a lot of automation, and AI helps us to automate security processes. That's very important. And just not exactly security thing, but I wanted to recommend these 2 books. If you haven't read that, I would suggest to take that. You have that on Amazon. You have that Kindle edition, electrical edition, mobile phone edition, so you can use this. And now we are going to real demo. So we have now technology to switch to a laptop which will show demo, and Vladimir is over there, so he will be showing how this really works. So Vlad, over to you.
Okay, thank you.
So he does real work, I'm just talking about in general, about conceptual things.
Thank you. I will perform a brief demonstration of 2 of our products, Glog and Impressec. First, I will start with Impressec, and here what you see is actually administration panel of Impressec product that is available through.
Can I interrupt you for a minute? Do you know what is the difference between machine learning and AI? You probably know theoretical definition, but if that is PowerPoint, that's AI. If that's some Python or C++ code, which Vladimir showed, that's machine learning. So we are showing now machine learning mechanism to fix that. So it's not just PowerPoint.
But if it's PowerPoint, then that's AI.
Yes, PowerPoint is AI, is global knowledge. So better marketing means AI, but a little bit close to reality is machine learning, because we can really do that. Don't take this seriously. What?
Okay, so here what you see is a dashboard of our Impressec product. At the top of this page, you can see classification of events that we detected, and there are 4 severity levels: low, medium, high, and critical. Low represents all these information gathering attacks. Medium severity represents all vulnerability assessment attacks on your system. High alerts are related to actual penetration attempts, and when penetration succeeds, then it is critical and it is real exploit. And down there you can see a timeline for last hour. You can see alerts reported to this demo environment, and I will use these alerts to show you how it looks like when a security analyst analyze this. In this product, we paid most attention to engine that is working beneath that, and we don't have so advanced graphical interface, so you will notice that we are using GUIDs to identify all these alerts, and we have presented basic data about each vulnerability, about each vulnerable TCP session, as we are analyzing TCP network data on TCP level. And what's more important to say, we don't analyze any payload that could represent some private or proprietary data. So we are just looking metadata on TCP IP level. We have our way how to preprocess this data, how to give that additional context, and how to feed that to our machine learning models. Here you can see source address, IP address, source port, destination port, and protocol that is used for this suspicious session. This could be used by security analysts to analyze this into more details and conclude, is this a genuine report or is it a false positive? If it is a false positive, we implemented functionality that is called security analyst in the loop, where security analyst could use this knowledge to annotate this vector and to add that to data set that will be later used for training. For each alert, security analyst can enter comment, test comment, for example, here, and say, is this true positive or false positive? If it is true positive, it can be classified as some general attack if there is not enough data to analyze and to conclude what actually happened, or it can tell it was information gathering, vulnerability assessment, penetration attempt, and actual exploit. And also it could suggest either to use this for training purposes or to add this to testing set, or security analyst can say any, and then our system will decide where this vector will be added. So once the vector is added, it is added to our training set. I will show you one of our training sets so just that you can take a look. So we added data sets to be accessible through web interface. Most of the data in our data set is actually numerical. So we process all these TCP headers in numerical data. It will take a couple of seconds to load, and we have some categorical data. So I will show you one vector from our data set that contains tens of features that we are extracting from the network traffic and how it looks like.
One important thing here, we use supervised learning, we use unsupervised as well, or deep learning. And better results are with supervised learning for some things, and creating these data sets is really a laborious work. So you need a lot of security analysts to create data sets, and we spent a lot of time we were giving this tool to actually companies that were eager to annotate events. And like AI, where you can recognize butterfly from the beard or whatever, average person can do that. But here you need security analysts, security people, real. So big accuracy of this system, we can thank to really security analysts that we learn from. So that's how we achieve this 99+%.
And here you can see how one vector looks like in data set. So it's mostly numeric data. Once the data set is prepared, we have another functionality that is called models. I will find models related to this data set that we were looking. So we have models for general attacks, and then to identify information gathering, vulnerability assessment, penetration attempt, and exploits. I will take this classifier that classifies traffic to normal or anomaly. We have some basic metadata about that model, but what is more important, you can run training process by executing this retrain button, or you can schedule that to be executed automatically in the background. Whenever training is done, you get new version. We use sequential numbers just to label each new model. Once new model is created, you can correlate this model to your sensor. I will take one sensor. Here you can see metadata about the sensor. You can block sensor. You can reload the sensor. We have information in XML format what is actually sensor is looking on the network. And as I said, here you can choose any of these trained methods here, models here, and then as soon as you choose it here, default polling interval is 5 minutes. So inside the time frame of 5 minutes, this new model will be downloaded to your network and used immediately to classify traffic. So that is basic functionality. Besides this, we have activity log for all activities that are performed here in our system. It is required by different auditory regulatory requirements, so we are providing that, so you can see all the action that I performed here. I watched whitelist elements, client details, training sets, model containers, and things like that. So with these functionalities, we actually managed to implement a security analyst in the loop concept and automate that process completely from data collection, labeling to training of machine learning models. So this was a brief demonstration of Impressive system. Now I will switch to GLOG.
While you're switching to GLOG presentation for software security, just to say, when I started this research, this was not kind of a riding of AI. Everyone is riding last 3-4 years. I started this 2021-22 and used NeuroSolution software. Probably nobody can recall that software in C++. And creating new model required like 14 days. So with that hardware on that time and data sets. So I had to wait 14 days on my computer, if that is up and running and doesn't fail, and get model and find out that model is maybe not good. So change one parameter and go again 14 days. Today, what Vladimir showed here with current power of processors and AI processors specifically, and also data sets, we can do that in 2 to 3 minutes. So why AI overpromised but haven't delivered that time? Because of lack of data sets, of connectivity and processor power. We now have all of this. So that's why we're going farther. And algorithms that we use today are a little bit more advanced than that time, but I would say that basic theory behind AI algorithms haven't changed too much for, let's say, 20, 30 years. Basic theory behind that.
Okay. Here you can see my development environment. Actually, GLOG is a product that is used in software development by software developers and software architects in early stages of software development lifecycle. Current static application security tools have a lot of problems, and main problem with these tools is actually low accuracy caused by big rates of false positives and false negatives, and also these tools have problem to understand applications and to properly identify attack surface. So, and all these problems are actually caused by these tools not understanding context of application. They don't understand application that is used, that is scanned. They don't know logic that is implemented, and they apply static patterns to all applications, no matter which logic is implemented in source code that is analyzed. So here, first I will show you how one of static application security tools, classic tools results looks like. So here you have results from Spot Bugs tool that is widely used in Java community. It is open source tool. It's a decent tool. It has good scan coverage, but produces a lot of false positives. And you can see that here we have 456 reported alerts for some application of medium size, around 10,000 lines of code. So it's a huge number of reported alerts. And what is more important when it comes to remediation advice, for example, if you use REST API, this application will report you just short alert telling you, you can see the text here, okay, you're using REST API, receiving some input data from the outside of your application, and you need to be careful with that, and nothing else. And if this is genuine alert, developer would not know how to fix that. Now I will switch to other development environment where we have GLOG running, and you can see that GLOG actually reported 88 items, so its number of alerts is significantly decreased. And what is more important with GLOG, we are analyzing context of application. Context of each application, of each software product is contained in 3 places. First place is actually source code itself, tokens that are used to write source code. They hide a lot of information. Also, underlying structure beneath source code, abstract syntax tree contains a lot of information. And third place where you can find information about your source code is actually related to environment, in which source code is executed, and information about environment are usually coming from architecture documents and from threat models. And we are integrating all of that to collect context and to perform in context triage of security alerts and also provide context-specific remediation advice. And for this specific application, for example, if we take a look, this same alert that we have seen in spot bugs, you will notice first that we extended this static part that contains description of vulnerability. But what is more important, our system learned that for this type of vulnerability, developers usually use bin validation pattern to fix this vulnerability, or they use custom whitelist methods to perform input validation. Also, our system decomposed input data, analyzed its context, and concluded that the best way to fix this vulnerability is actually to use whitelist regular expressions to perform input validation. And for each field that could potentially carry tainted data, it provided specific regular expression with advice of which length that input data should be. So you can see that we have different properties coming through. Usually, these data are coming through JSON, so it's a string, JSON string, that is automatically deserialized into objects inside your code, and these objects usually have fields, properties that could contain malicious data. And you can see that in this case, our system properly identified this and offer context-specific remediation advice for each property in this source code. Another component, what you see now is a plugin that is part of integrated development environment. And this plugin is communicating with our Glog server. So this is our main Glog server. And all predictions, all context mining is done actually here in this server. And we have a couple of important features here. One important feature when you take a look at the beginning of scanning process is actually this process that we named threat model, where we collect all namespaces, detect all namespaces in application, classify them by input type. We identify all REST APIs, SOAP APIs, all file reads, database reads, communication with external services, all open sockets. And now security architect or developer can use our server and, for example, come here and tell, let me find alarm controller class. Okay, here, in this actually. I will find alarm controller class. And I will tell, okay, this class is part of my API, and by architecture design, it receives data from remote users. So it's very risky, but our environment contains, for example, web application firewall, input validation, and sanitization. And I will save this. And this is, oh, actually, some error occurred. Okay, so probably due to connectivity. But in this way, our system will save this data and will use that later in a process of automatic triage to use this information, because it's very valuable. For example, if web application firewall input validation is done on web application, on web server, then you don't have to do that in source code. Also, context mining. We analyzed each method. We analyzed each data trace, data flow, and each method. And we process in our specific way each method to extract information and pass that to our AI models. And for each method, we are performing predictions of actually summarize what each method is doing. In that way, we can detect all input validation methods, all sanitizers, all encoders, all blacklists. So all these methods that are interesting in security context. And you can see here you can see the table. On the left side of the table, you can see method signatures, and on the right side, you can see predicted caption of each method that is used in automatic triaging process. Also, when it comes to remediation advice, all remediation advices, context-specific remediation advices are cached here. And here, for example, you can see what our system predicted in case of vulnerable SQL queries, how to fix that, and how statements are prepared to be parameterized. So this was a brief presentation of our GLOG system.
And I have, you know, Steve Jobs used to say one more thing. I have 3 more things. So if you just can go back to presentation to last slide, so people can get URLs if they want more information. Glog.ai is startup, fully funded by our personal money, and no external money, no venture capital, no anything. We developed that to level to 12 clients, mostly in North America. I don't know why we have not success here in this region. We probably not doing good in this region, but better in North America and West Europe. And we now were approached by one of the biggest companies in the application security area, talking to us to probably partner or acquire. So that's interesting development, which we are very proud of. Impressec is another project for network security, and it's mostly for security operation centers. And security predictions is actually a side project that says, okay, we can predict what will happen next, who will be next victim of attack. But it's very tricky because if they learn, you know, they will attack someone, they will change their target. So we deliver that information just as per subscription in confidential way to potential, and they then prepare. I'm coming a little bit from military. I have here a colleague and also some other in political world. So I say we increase alert level, and they are focus their defense on most probably place which are most probably next targets for attack. So that's it. If you need more information, visit these websites, or you can take mail address and can ask. Also, we will be around here, so you can ask more questions if you need. If someone wants to test this, also we can talk about this. Thank you very much. I don't know if there is time for questions. Probably we are over time, so whatever.
Yeah. We will have coffee break at 11, so you can ask now.
Thank you very much.
Thank you both. Thank you for the great presentation and the demo.